change. So we said BGP will not automatically update their neighbors, even though they have become peers. They will never send an update unless you tell them to do so. So the next topic is how to advertise BGP routes. Advertising BGP routes. That is our next topic. Advertising BGP routes. You can either do advertise routes by using the network command. So how do we do that? And router, let's say BGP 50, for instance. Then if you want to advertise a network of, let's say, 3.3.3.3 with a mask, let's say if it's a /24, okay, let me put 0 here. It's a /24, then 255.255.255.0. By using this statement, you can advertise. You can. Notice you will. You can. I'll explain why. You can advertise a route. 2, you can also use the redistribute. Statement to advertise routes. So we have 2 methods, either using the network statement or using the redistribute statement. If you want to use the network statement, this is the syntax. Okay, that is the syntax. Let's go to our topology. So right now, this router 6, has now become neighbors with router 1, eBGP neighbors. They haven't advertised any route yet. But if you look on R1, we have some routes. Remember the loopbacks that I configured. Enable show IP interface brief. We have some networks, okay? We are using this one for our peering, but we are assuming that all these routes are routes that have been received or routes that are directly connected to us. So let's show the routing table on R1. So show IP routes. And that is our routing table. BGP is so funny. Do I say it's funny or it's strict? If you want to advertise a route, that route must be in this routing table. It must be in this routing table before you can advertise it. Else, forget about it. It won't work. That is BGP for you. And this route here, directly connected. What is the subnet mask? Please, that's a /32, right? Okay, they're all /32. To advertise a route, let's say R1 wants to advertise a route to R6. That route must be in this routing table. So let's advertise this one here. It's a /32. This network here is a 32/32. You must be specific on the subnet mask, else it will also not work. So we go on R1, and if R1 has received the route, how are we going to know that? So first of all, check the topology table, isn't it? The topology table is a table which has all the raw materials, all the raw routes or raw networks that a router has received. Then it will filter out the best routes and drop them on the routing table. So let's see whether R6 has received any route in this topology table by showing eBGP. That's the command if you want to see the topology. Show eBGP. We enter and there's nothing. It hasn't received any route. Okay, from R1, it hasn't. So now we go on R1 and we want to advertise this network. If you like, let's try to advertise a network which is not in the routing table of R1 to see whether we receive it on R6. Let's do that. So conf t. We don't have 3.3.3.3. So let's do that. So router BGP 50 network 3.3.3.3 and a mask. Mask of /32, so 255, 255, and 255. We have advertised this route, even though it's not in the routing table. Will R6 receive it? Come to R6 and show the topology table. Nothing. It's not there because R1 doesn't have the route that it's advertising in its routing table. R3, 3.3.3 is not here. So let's advertise first 172.16.10.1/32 using the network command. Network 172.16.10.1 and a mask. Of enter. Let's see whether R6 will receive this route. By showing the topology table, show eBGP, enter, and there we go. We have received that route. Watch it. It has been received. And what's the next stop? Take note. The update source of R1. The update source. We specified it on R1 that if you are receiving any route from me, this is the source of my update. That's my loopback 1. So R6 is saying that, oh, I didn't receive it from an interface, but I received it from a loopback. That's the next stop. What do we see here? Let's take note. We see I and we see 50. What is the meaning of I? Internal. And what is the 50? The route has just emerged from autonomous system number of 50. So let's come to the board. AS50, AS100. This is R1. and R2. This network that we just advertised is a loopback. Okay, it's 172.16.10.1/32. Because we use this first option, the network statement, this router here is seeing this, this network as internally generated. It was generated from this network. That's how come we see the I. Okay, so first I, internally generated, and now it moved from AS number 50 to R6. That is why on R6 we see I and 50. First, that route was internally generated and it came out of autonomous system number of 50. Then I received it. So in this case, if there was to be another AS here, okay, connecting to R6, and that happens to be AS, let's say 200, and this AS has received this same route here, the path will be something like this. Internally generated 50 and 100. So if you show the output on this router here, you will see that this route 172.16.10.1 was internally generated from this AS number, and it moved to AS number 100, then it came to me. We call this one AS path, autonomous system number path. AS number path is very key in BGP, very key. And the routers use this a lot. It helps them in loop prevention, okay? So we'll see how BGP uses AS path as a means of loop prevention. Let me even touch on it. It's so simple. Okay, we don't want the routers to loop, or we don't want the route to loop. So supposing this AS number is somehow connected back to this router. Let's assume it's connected back to this router. Okay, and this router, upon receiving the same path that it's advertised, that will record, we are continuing from here. It will record internally generated, came from 50 and 100, and now it came from 200, and I received it here. Now this router will say, hold on. I'm seeing myself here. For this reason, I'm going to discard the packet. Loop prevention. Okay. BGP uses AS path to prevent loop, because if it allows the packet to move, then the packet will go around again, come here again, and go here, come, go, it's loop. So every AS path, when it received a route, it will check the chain to see whether it's seeing itself. If it's seeing itself, that packet will be dropped, thereby preventing loops or checking loops. So that's how AS path, that's just by the way. I'm even lost. Okay, so we just advertised the routes and we explained the I here and the 50. And let me explain this one too. We can see some asterisks here and a greater sign here. Let's find from the code. Asterisk means what? The route is valid. And this one tells us that we have a best route. If it's a best route, what does it mean? It means to enter the routing table, isn't it? So this is the topology table. We are just saying this is a very simple network. That's why we are seeing just one entry. But in complex network, there's a lot of them. The best one will enter the routing table. So let's check the routing table. And the command is show IP route. What are we seeing? We are seeing a BGP route in the routing table for this network. And it's via what? The loopback of router 1. And what here? For eBGP, it has an administrative distance of 20. iBGP has an AS number of 200. We'll see that when we are doing iBGP. But eBGP has an AS number of 20. You see, the best route has entered the routing table. So we have seen the first method of advertising a route. When you use the network statement, we are going to see the route as internally generated. Okay. So show IP BGP. We see this as internally generated. Okay, let's go on R1 again. Now we want to use the redistribute. We want to use the redistribute to advertise routes. And remember, all the routes that you advertise should be in the routing table. First, let's check the routing table again. Show IP routes. And this is what we have. I want to redistribute all the connected routes. Okay, all these routes are connected. You can see C by them. C means connected. Or CC any days. You know that C. Oh, what did I just do? Show IP routes. C means the routes are directly connected to R1. I want to advertise all the connected routes using the redistribute statement. Then we'll see the difference. How that one differs from the network command. So let's go. Conf router BGP 50 redistribute connected. See, we don't have to redistribute all the connected routes. We can use route map to filter some. Okay, we haven't done route map yet. We'll do it. Don't worry. So redistribute connected on R1, and we expect the routes to come on R6. So let's go on R6 to check. We are first checking the topology table first. So show IP BGP, that's the command. Please take note of the commands. Show IP BGP summary is when you want to check the neighbor table. This is for the topology table. And we have some entries. Watch. All these routes here have been received. And take note, what are we seeing here? Question mark. But we still have some I here. And the question mark. What does that mean? Question mark. Let's go on this. Question mark means what? Incomplete. Question mark means what? So anytime a route is redistributed, it's advertised through redistribution, that is what we see. So guys, take note. Just keep an eye on your tables. Okay, as administrators, you need to understand the output of your network. Anytime you say this, straight away, you know that, oh, from the origin, that route was originated, was redistributed inside of autonomous system number 50. Then it came to me. So this route here is a best route and is valid. And it was received via the loopback of R1. And R1 is in autonomous the lip is going faster than the brain. autonomous system number of 50. And this one was internally generated. You remember the one that we use the network statement to advertise. That is it. And the rest are. But I want to talk about this one. I will close here. Okay. You see, there are seeing some two routes here that have what? R and this. It doesn't have the asterisk. If it doesn't have the asterisk, that means that route is not valid. It should have asterisk. That will tell you that it's valid. And what's the meaning of R? It says RIP failure. RIP means routing information base. Or in other words, your routing table. Your routing table. This guy failed entry. It wasn't allowed entry inside the routing table. So let's watch our routing table, okay? If you see a routing table, we'll see that all these routes are there. Let's keep an eye on the 10, 172.16.10, 172.16.20, and 172.16.30. They will all enter our routing table because if R6 should make a routing decision, it will not come to the topology table. It will go to the routing table to fish out the best routes. So all the best routes are there in the routing table. So let's go there. Show IP routes. And what are we seeing? They are here. B for BGP. That's what we are looking at. B for BGP. The 10, the 20, and the 30, they're all here. So those routes can be reachable. It can be reachable. But do we see the RIP failures? This one. 1.1.1.1/30. And the connected network. You see the connected network is here. 10.0.0.4/30. Do we see the routing table? Is there? Yes, it's here. Is it coming from BGP? No. What about the connected network? This one. It's not coming from BGP, but all these guys are coming from BGP. You see, BGP is somehow angry that I have this in my topology table. Let's check the topology table again. I have all these routes here in my topology table. I want to put them in the routing table and you are not allowing me. Meanwhile, those routes are still there. You see, we have administrative distances for every routing protocol. As we all see, BGP has an administrative distance of 20. But watch here, static route here. Static. For the 1.1.1.1. What do we see? What's the administrative distance? 1. The lower, the better. Lower administrative distances are better. What about the connected network? We are putting our attention on the RIP failures, the network, the RIP failures. This one. Okay. That's where attention is. So this is also the connected network. And we are saying that it wasn't BGP that advertised it, even though it's in a routing table, but it wasn't received through BGP. It's directly connected. This one is also directly connected. This one is a static route and it has an AS number of 1, which is better than eBGP's AS number. In fact, for the connected routes, the AS number is even 0, far better than 20. That is why the route from BGP was ignored for this particular route, the 1.1. It was ignored. Okay, so RIP failure is not anything bad. Okay, it's not anything bad. If you see RIP failure, don't get scared. Your router here is telling you that, oh, this guy's here failed entry in the routing table. They were denied entry because there were better options. There were better options. BGP couldn't find its way of entering this route in the routing table because static route was there. You remember the static route? Let's check. So, there's a static route. Oh, I went too fast. Where's that static route? This one, for the 1.1.1, we entered it. I'm sure we haven't forgotten. We entered this to the loopback. Okay, so this one is more preferred than the one from the eBGP. That is why we see the RIP failure, but that is not a bad thing. If you see RIP failure, don't shake. So now we have seen how to form eBGP peers. We have also seen how to advertise or to pump routes inside the eBGP network. Today's class, we can draw the curtain here. For now, next week, if God permits, we'll continue. Please, is there any question? Are there questions for me?
I mean, first of all, please, I see that we've had a number of breaks in the session because of the Zoom time limits. But I wanted to know if I'm sure some of us missed some parts of this lecture. So if we could have the recording so we could go back.
Oh, yes. For every class, I'll send the videos. I'll do that right away for every class.
Okay.
Okay. Any other question, please? Okay. Kofi?
Hello, Nat. I'm not sure if I'm jumping the gun, but I just wanted to find out from this. Why is it so important that we advertise with the loopback? Because I am seeing that like from the router 1 to router 6, if the link between them breaks, you will not be able to reach the loopback on router 6, correct?
Yeah.
Yeah, so why is it important, or why is it better to advertise with the loopback?
Okay. Let me just use this opportunity to explain. I wanted to hold on for the next class, but don't worry, let me explain. Okay, so let's do peering for these 4 routers. Router A and router B, they want to peer. This interface is 1.1.1.1. That is 2.2.2.2. And the loopback is 3.3.3.3. You have an IGP running on this network because the requirement for BGP, there should be reachability, and reachability can be achieved through static IGP or connected. So IGP, like let's say OSPF is running on this network. Let's assume we peer with 1.1.1.1. Router A knows 1.1.1.1. It can ping one because it has to be reachable on it. The pinging should go on before the peering can. If the ping fails, no peering. So if this link here goes down, router B is lost, even though there's an alternate path to router B. You remember? Router B is lost because you have peered using an interface. Router B is lost. then in that case, you have to delete the peer and come and pair with this interface again. What if this one also goes off? But if you pair with a loopback, on this loopback, it can either be reachable through this link or through this link. You get it? If you are doing eBGP, you know what I'm talking about. You can ping this one. If the ping is coming, it can go through path A or path B. So path A can go down. There's still reachability to the loopback. That is why it's advisable to use loopback for our peering.
Great, thanks.
Okay.
Yes.
Please, any other question? Any other question? Okay, so if there's no other question, we will draw the curtains. I'll send some assignments, okay? You should start playing with the configuration. Even though we haven't done much, but let's do some configurations. The more we configure, the more we know. Thank you all for coming and hope to see you next week. Goodbye.